Okay, Assalamualaikum and good morning. Okay, so we will start our lecture for today. So basically, for today, boleh dengar kan? Can you hear my voice?
Dengar doktor, dengar.
Okay. Okay, so basically for today, we will continue with chapter 2. So chapter 2, which is the Wye-Delta transformation. Okay, so what is Wye-Delta transformation? So if you remember last week in the previous class, you have learned on how to calculate for the R equivalent. Okay, so given a circuit, you are required to calculate the R equivalent. Okay, but the thing is, to calculate for the R equivalent, you need to know whether the circuit is a series circuit or a parallel circuit. So then only you can simplify the circuit and then you can calculate for the R equivalent. But what happens if the circuit is not a series circuit and is not a parallel circuit? So how to simplify the circuit in order to calculate for the R equivalent? Okay, so over here, if things like this happens, that's why we need what we call as the Wye-Delta transformation. Okay. Okay, so over here, stated over here, the some resistors are combined neither in series nor parallel. For example, you have this figure over here. Okay, this circuit, this is not a series circuit, it is not a parallel circuit. Okay, so what happens if the question asks you to calculate the R equivalent? How to find the R equivalent for this circuit? Okay, you cannot simplify this circuit because it's not a series circuit, it's not a parallel circuit. Okay, so this type of connection can be simplified by using what we call as the three-terminal equivalent network. Okay, three-terminal equivalent network. Okay, so for the three-terminal equivalent network, we have two types. So the first one is the delta network. The second one is the Y network. Okay, so we have two types of three-terminal equivalent network. So this is the first one. This is the delta network. This is the second one, which is the Y network. Okay, so if you have a circuit like this, okay, you have a circuit like this, you can see that it is not a parallel circuit, it is not a series circuit. You cannot say that RA and RB is parallel. This is not a parallel circuit because you have RC over here. If you don't have the RC over here, then RA and RB is the parallel connection. Okay, same for this one. Okay, this is not a parallel circuit, it is not a series circuit. Okay, so R1 and R2 is not a series circuit. Why? Because you have R3 over here. If you don't have R3, then you can say that R1 and R2 is a series connection. Okay, so this type of connection, we call it as delta network. This one is we call as the Y network. Okay, so if for this circuit, you can actually redraw it. You look at here, you have three nodes, A, B, and also C. So this is one node. So if you redraw this circuit, you will get this circuit, a circuit like this. For this circuit, same, if you redraw the circuit, okay, you have A, B, and also C, three nodes. So you have A, B, and also C. So you redraw, you will get something like this. Okay, so if you look at this figure over here, so this is a delta, we call as delta network, and this you can see that this is a Y. That's what we call as the Y network. Okay. Other than that, we also call this one as the pi network. Pi. You know what is pi? Pi is something like this. This is pi. So if you look at here, this is a pi. So sometimes we call this network as a delta network, and we can also call this as a pi network. Okay. For this one, sometimes we call it as a Y network, sometimes we call it as a T network. T. T is actually T. Okay, T. So this is T. Okay. So delta or pi or Y or T network. So the Y or the T network, the Y network also can be called as a T network, and the delta network can also be called as a pi network. Okay, so, and the Y network, but usually we use the Y and also the delta network lah. Okay, so the Y network can be converted into a delta network and vice versa. So meaning from a Y network, you can convert it into a delta network. From a delta network, you can convert it to the Y network. Okay, so this conversion is used to simplify the circuit analysis. Okay, so you need to take note that this conversion did not take anything out of the circuit or put anything new. It is actually the same circuit, it's just that you change the connection of the circuit. Okay, so over here is an example if you want to convert from a delta network to a Y network. Okay, so you know that a delta network, you have something like this. Okay, and you want to convert into a Y network. Okay, initially you have this one, the yellow one. This is delta network, and now you want to convert it into a Y network. The Y network is this one. Okay, so when you want to convert from delta to Y, then you need to calculate for the value for R1, R2, and also R3. And this is the formula for R1, R2, and also R3. Okay, and you need to remember this formula. It's quite easy to remember actually. If you look at here, for the resistor 1, resistor R1 is over here. So the formula is actually, okay, you look at here, we have RB, this resistor, multiply with this resistor, which is the RC, divide by RA plus RB plus RC. For the R2, okay, R2, so this resistor, which is the resistor RA, multiply with the resistor RC, then divide by RA plus RB plus RC. And lastly, for the resistor 3, so since the resistor 3 over here, then it is equals to the resistor over here, multiply with the resistor over here, divide by RA plus RB plus RC. Okay, so you must remember this formula. So this is if you want to convert from a delta network to a Y network. Okay, next you can also change from a Y network to a delta network. Okay, so over here you initially you have the Y network, the blue one over here, and you want to convert it into a delta network. Okay, this one. So then you need to calculate for the value for the RA, RB, and also RC. And these are the formula for RA, RB, and also RC. Also, you need to remember this. Okay, I'm not sure whether it will be given, okay, in your final exam. Okay, but since your final exam is open book, so maybe you don't need to remember lah the formula. Okay, so for the RA over here, you look at here, for the resistor RA, so if you want to remember this one, it is actually R1 multiplied with R2, then plus R2 multiplied with R3, then R3 plus R3 multiplied with R1, divide by, this is RA, divide by R1. For RB, the same. On the top here is the same. R1 divided by R1 R2 plus R2 R3 plus R3 R1. Then divide by R2 because RB is over here, so it must be divided by R2. For RC is over here, then it must be divided by R3. Okay. So these are the formula. This one to convert from delta to star network. This one to convert from star to delta network. Star is actually Y, Y. Y. A-Y. W-Y-E. Okay, we can also call it as a star. Okay, so this is delta to Y, this is Y to delta. So this conversion is very useful when the resistors are neither in parallel nor in series. Okay, so now let's look at the first example. So you were given a circuit. So this is a delta network. Okay, the question asks you to convert to a Y network. Okay, so in order to convert to one network, then you need to find the value for R1, R2, and also R3. Okay, so just use the formula in the previous slide. So you have R1 is equals to RB, RC, divided by RA plus RB plus RC, and so on. R1, R2, and R3. And then you just put in the values, and you will get the values for R1, R2, and also R3. Okay, so you can try this. You put in the values. So the R1 you should get 5 ohm. R2 you should get 7.5 ohm. R3 you should get 3 ohm. Okay, you just use the formula and you can directly get the value for the R1, R2, and also R3. Okay, then after you calculate the value for R1 and R2 and R3, then only you can draw the converted circuit. Okay, this circuit. So previously you have a delta network, this one, but now you already changed to a Y network. Okay, so this is the Y network. Okay, so this is R1, the ones that you calculated just now. This is R1, R2, and also R3. Okay, so basically this is how you convert from a delta network to a Y network. Just simply use the formula. Okay. And okay, so next is the second example. No questions regarding the previous example. I think it's quite easy. You just use the formula and you can get the R1, R2, and also R3. So the next example is to convert Y network to a delta network. Okay, so this is a Y network. Now you want to convert it into a delta network like this. Okay, so this is RA, RB, and also RC. So you need to calculate for RA, RB, and also RC. So just use the same, just use the formula. So RA is R1 multiplied with R2 plus R2 multiplied with R3 plus R3 multiplied with R1 divide by here. If you redraw the circuit, it is actually something like this. Okay, so if you redraw the Y network, this is actually R1, this is R2, and this is R3. Okay, so RA you must divide with R1. So R1 is 10 ohm. So you will get RA equals to 140 ohms. Okay, for RB, so look at here, RB is over here. So you need to divide it by with R2. So R2 is 20 ohm. Okay, so 1400 divided by 20, you will get 70 ohm. Okay, and lastly, RC is over here. So you need to divide with R3. So R3 is 40 ohm. So 1400 divided by 40, you will get 35 ohm. So then you can redraw the delta network. Okay, so this is RA is 140, RB is 70 ohm, and this RC is 35 ohm. Okay. So now let's look at an example where you can see where this Wye-Delta transformation is very useful. Is used. Okay, so someone asked, ada bentuk lain juga ke selain segitiga? No, we only have two. We have Y network and also the Y network and also Delta network. Okay, only two connection, two network. Okay, so next is another example. Okay, so if you look at this example, you were given this circuit. The question asks you to calculate the RAB. RAB is the R equivalent. RAB is the R equivalent. Remember last week lecture how to calculate for the R equivalent. Okay, so RB is the resistor looking from this part. So this is RB. So the question actually asks you to calculate the R equivalent. But the thing is, if you look at this circuit, you cannot simplify this circuit because it's not a parallel circuit, it is not a series circuit. Okay, so that's why you need to convert it either in delta or in a Y connection. Okay, so if you look at the first example over here, the first one over here, if you look at this part, this is actually something like this. Okay, this is actually a delta network. If you redraw this, part, only this part, this is actually a delta network. You look at here, if you redraw, you have 5 ohm, 10 ohm, and this is 12.5 ohm. Okay, this is actually a delta network. Okay, so what you can do, you can convert this delta network, delta, you can convert it into a Y network. Okay, not Y. Y. Okay, convert from delta to a Y network. So to convert from the delta to Y network, then you need to find the value for R1, R2, and R3 using their formula. Okay, so R1 is use this formula, then you can get the value for R1, R2, and also R3. Okay, then after you convert, you can redraw this circuit and you can get this circuit. Look at here. Previously, it is a delta network. Then you convert it into a Y network. Now this is the Y network. Okay, so you calculate the value and you can redraw it to become a Y network. So from this circuit, then only you can simplify the circuit to get the RAB and also the current. Okay, so maybe you can try this one by yourself. You should get the R equivalent is equals to 9.632 ohms. Okay, so after you get the R equivalent, then use the Ohm's law, V equals to IR. So I equals to V over R. So R should be R equivalent. So you can get the value for the current, which is 12.458 ampere. Okay, so this is one method. Okay, to solve for this circuit, you can also use another method. Okay, this is the same circuit, the same circuit as the previous one. However, the previous one, we changed this part from delta network to a Y network. Now I want, instead of change this part from a delta network to a Y network, I want to change this part. Okay, so if you look at here, this is a Y network, Y or a T network. Okay, so I want to convert this part to become a delta network. Okay, so now I need to calculate for RB, RA, RB and also RC. Okay, so use the formula. This is the formula for RA. This is the formula RA, RB and also RC. So RA, just put in the values here. You will get RA equals to 65. RB you will get 21.667. RC you will get 26. Okay. So from this circuit, okay, this is the same circuit. It just said I redraw this. So this you can see clearly that this is the one. Okay. So now I convert it to a delta network. So now I have RB, RA, RB and also RC. Okay, so from this circuit, I redraw it using a delta network. So now from node A over here, okay, I have RA. Over here I have RB. And over here I have the RC. Okay, so from after we convert to a delta network, then only we can simplify the circuit. Okay, then only we can calculate for the R equivalent. So if you look at here from this circuit, you can know that R, this is 10, this is 20, this is 30. Okay, so if you look at from this circuit, you can see that resistor RB is in parallel with 10 ohm. Okay, so you find the R equivalent 1. This is, for example, I name this as R equivalent 1. So R equivalent 1 is actually RB parallel with 10. So you calculate, so you should get the value of 6.842 ohms. Okay, another one, RC is actually in parallel with the 20 ohm. Okay, so you calculate for the R equivalent to, for example, this is R equivalent to. So R equivalent to is actually RC in parallel with 20. You calculate using 1 over RC plus 1 over 20. Okay, so RC is 26. Okay, so you calculate, you should get equals to 11.304. Okay, so I simplify the circuit, I redraw the circuit. Now my circuit is, this is R equivalent 1, which is 6.842. And this is R equivalent 2, which is 11.304. Okay, and now you can further simplify to calculate for the R equivalent. So you know that this is in series. Okay, after you find the value for this part, then you can calculate for the R equivalent, where RA is equivalent to this resistor, equivalent to 30 ohm. So you should get the R equivalent or the RAB is equals to 9.632. Okay, this one. This is in series, that's why 6.842 plus 11.304. So this resistor, series resistor, is in parallel with RA, is in parallel with 30. So it is equals to 9.632 ohm. Okay, this symbol actually means parallel. Yeah. So if you have RB 10, this is actually RB parallel with 10. Okay. So any question for this example 3? If you did not convert this circuit into either a Y network or delta network, then you cannot find the R equivalent. Okay, so you really need to know how to convert or to Y network or to delta network. Okay, but it depends on you whether you want to use method 1 or method 2. Method 1, this part I change it to a Y network. Second, instead of a Y network over here, I change this to a delta network. Okay, then only you can get the R equivalent. Suppose you will get the same answer. By using this, you will get R equivalent 9.632. Using this method also, you will get RAB is equals to 9.632 ohm. Okay, so you can try by yourself and compare these two methods. You should get the same value for the R equivalent. So another example, okay. So you have a circuit like this. The question asks you to find R equivalent, RAB. Okay, so RAB and also the current I. Okay, so this is not a series circuit, it is not a parallel circuit. But if you look at this circuit, you can see that this is a Y network. Okay, so from Y network, you can change it to a delta network. Okay, so now I want to change this part from Y network to a delta network. So I need to find the value for RA, RB and also RC. So you just use the formula. So you should get RA equals to 34, RB equals to 85 and RC equals to 170. Okay, so then only you redraw this circuit using the delta network. Okay, so previously the green one is the initial circuit. Okay, so the new circuit is the one with the blue color over here. This is a delta network. Okay, so you redraw, your circuit will actually become something like this. Okay, RA, RB and RC. Okay, so now you can calculate for the R equivalent. So from this circuit, you can know that RA and 24 ohm is in parallel. Correct? RA and R and 24 ohms is in parallel because this is the same node. Okay, so this RA and 24 ohm is actually a parallel connection, and RC and 30 ohm is a parallel connection. So if you calculate for example, this is R equivalent 1, this is R equivalent 2. Okay, so R equivalent 1, you should get 14.06 times. R equivalent 2, RC parallel with R3, and you should get 25.5 ohm. Okay, then you redraw the circuit, you will get something like this. This is 13 ohm. This is R equivalent 1, R equivalent 2. This is RB. Okay, so from this circuit, you will get this. This is RB. This is R equivalent 1. This is R equivalent 2. This is 30 ohm RAB. So find RAB. So you need to simplify the circuit. This is a series circuit. So that's why 14.069 plus 25.5. This is in series. Okay. Then you will get the R equivalent 3. So this R equivalent 3 is actually parallel with the RB. So that's why this one you have this series connection parallel with RB. And then you further simplify, you will have a circuit like this, 13 ohm. Okay, so maybe this is REQ1 series with REQ2 is REQ3, and REQ3 parallel with RB, I call it as REQ4. So this is REQ4. So R equivalent is actually 13 is series with R equivalent 4. So you will get 40 ohm. So if you get confused, okay, how to actually simplify the circuit, then you need to do it step by step. Okay, but if you're already expert in simplifying the circuit, then you can just calculate like this. Okay, you don't need to do it step by step. But my advice, please do it step by step. Okay, first find R equivalent 1, then R equivalent 2, R equivalent 3, and last one, then only you can calculate for the R equivalent or the RAB. Okay, to avoid mistake, to avoid careless mistake, if you do it directly like this. Okay, so any question? Okay, so one question, for the labeling of RA, RB, and RC, is it randomly placed or according to order? What you mean? No, it's randomly placed. It is according to you. According to the circuit, according to the circuit. For example, for example, you don't really need to know, okay, this is RA, this is RB, this is RC. You don't actually need to know that. You just need to know that, you just need to know if you want to determine RA, this formula, okay, you just need to know that if you want to determine RA, meaning a resistor over here, then you must divide with the resistor opposite to it. This is R1. This resistor. You don't need to actually label this is R1, this is R2, this is R3. You just need to know that if you want to calculate this resistor, so all of this resistor multiply and add, but divide by the resistor opposite to it. Okay, is that your question? And am I answering your question just now? Can you show the calculation for the R equivalent again? Okay, which one? This one? Oh, no. Is this one? Equation for R equivalent? Yes, okay. Okay, so from this circuit, This is the Y network. I convert it into a delta network. So if I redraw this circuit, I will get a circuit like this. Okay. This is RA, this is RB, RC, this is 24, this is 30, and this is 13. Okay. This one I already convert to the delta network, yeah. So now you want to find R equivalent. If you look at here, okay, if you get confused with this circuit, you can actually redraw. Okay, this part over here is actually the same node. This is the same node, and also for this one, this is the same node. If you redraw this, it is actually something like this. It is actually 24 RA. Correct? Because this is node A. For example, this is node A. No, maybe I labeled it as node X. This is not X. This is not Y. So if I redraw this part, this is not X. This is not Y. This is actually in parallel. So that's why I said that RA and 24 ohm is in parallel. RC and 30 ohm is in parallel. So for example, I call this as R equivalent 1. So R equivalent 1 is equals to RA parallel with 24. R equivalent 2 is RC parallel with 30. Okay. So after you find the R equivalent 1 and R equivalent 2, then you can redraw this circuit to become this circuit. Okay. So this is R equivalent 1. This is R equivalent 2. This is RB. This is 13 ohm. Okay. R equivalent 1 is 14.069. R equivalent 2 is 25.5. Okay. Then you further simplify the circuit. This is a series. Okay. This is a series circuit. Okay. So this is, I name this as R equivalent 3. Okay. You need to calculate for the R equivalent 3. Okay dah. Thank you already. So this is what you want to know, right? The steps to find the R equivalent. Muhammad Amirul Haziq. Okay, so find the R equivalent 3. So you will get a circuit like this. RB, this is R equivalent 3. This is 13. Then this is in parallel. Okay, after that you will get a circuit like this. This is R equivalent 4. So R equivalent 4. This is 13. So this is in series. So you will get the value which is equals to 40 ohm. Okay. So that one is the first method. You can also change the circuit to become something like this. Okay. So if you look at here, this is the same circuit. So the previous one over here, we actually convert from a Y network to a delta network. But if you don't want to convert this part from a delta Y network to a delta network, you can calculate it like this. Okay. For this method, you actually change from a delta network to a star network. Okay. still you will get the same answer. R equivalent over here, you see that R equivalent is equals to 40 ohm. Okay, I think you can look through this second method by yourself. Okay, so roughly it is actually from this delta network, it changed to the star network. So you need to find R1, R2, and also R3. So using the formula, you will get R1, R2, and also R3. So then you redraw the circuit, redraw this part. So you will get a circuit like this. Okay, so when you get the circuit like this, then you can find the R equivalent. Okay. So this one, find the R equivalent step by step. Find the R equivalent 1, R equivalent 2, and so on. So this one, you know that 50 is in series with 3.704. That's why you get 53.704. Over here, this branch, 30 is series with 8.889. So that's why you get 38.889. Then you know that this resistor is in parallel with the resistor. Okay, so you withdraw, you will get something like this. Then only you can find the R equivalent or the R total, RT. So 13 in series with the resistor, series with this resistor, you should get R equivalent equals to 40. You should get the same answer as the previous example. Okay, any question regarding the Wye-Delta transformation? So if no questions, I want to continue with subchapter 2.14. Do you want to take a break or do you want to directly continue with subchapter 2.14? Do you need a break or can we just continue? Continue, okay? So, this one I've already uploaded this slide in the ULearn. So you go to week 5 and we have the subchapter 2.14, which is the nodal analysis. Okay. Nodal analysis is actually similar to the ones that you have learned previously, the KCL and also the KVL. It is actually analysis that involve KCL. Okay. So I hope that you still remember your KCL, KVL. Okay. Nodal voltage or branch voltage analysis provide a general procedure for analyzing circuit using node voltage as the circuit variable. Okay. Example 1. Let's look at example 1. Given the circuit, the question asks you to calculate for V1 and V2. Okay, the question asks you to calculate the voltage V1 over here and also the voltage V2 over here. Okay, so for the nodal analysis, we have steps. Okay, several steps. So you can refer to this slide. So these are the steps for the nodal analysis. You should follow this step. Okay, so step 1, assign nodes and name as V1, V2 and so on. The second step, you should assign the current direction at each node and name the current. The third step is apply KCL. Remember your KCL. Okay, apply KCL at each node. So the number of KCL equation must be equals to the number of nodes. So if you have 3 nodes, then you need to have 3 KCL equation. If you have 2 nodes, then you should have 2 KCL equation. After that, you need to substitute each current with the Ohm's law, and lastly, you must solve the resulting simultaneous equation to obtain the unknown node voltages. Okay, so now let's try and do example 1. So this is example 1. Okay, I hope you can see this clearly. So this is example 1. Remember, for the nodal analysis, we have the 5 steps. Okay, so first, look at here. So the first step is assign nodes as V1 and V2. Okay, so over here you have 2 nodes. This is node 1. This is node 2. Okay, so assign nodes as V1 and V2. So the first node over here I assign as V1. Okay, I hope you can see this. This is V1. And the second, this node I assign as V2. Okay. Next, the second step is assign the current direction at each node and name the currents. Okay, so assign the current direction. So now at node 1 over here, you know that the current flow at this branch is like this. Okay, it follows the current source. Okay, at this branch, the current direction should be like this. Why? Because current flows from positive to negative. Okay, and over here you have the ground. So supposedly the current will flow like this. Okay, and the current over here, the flow is like this. Okay, for the second node, okay, this is the current flow. This one flows to the ground. Also, same as this one, flows to the ground. Okay. So after you assign the current direction, then you name the current. So over here, I name this as I1. This is I2. This is also I2. Okay. And this is I3 and this is I4. Over here, I name it as I. Okay, it depends on you whether you want to name it as IX, IY, IZ. Okay, it doesn't matter. Okay, then after you name the current, you must apply KCL at each node. So the first node over here, you do KCL, Kirchhoff current law. Okay, so KCL at node 1, this is actually I equals to I1 plus I2. Correct? I equals to I1 plus I2. Okay, so that's why you have I equals to I1 plus I2 over here. And you know that I is equals to 1 ampere because this is the current source. So I is equals to 1. Okay, so that's why I have this equation 1 equals to I1 plus I2. So next you do the KCL at node 2 over here. Okay, so the KCL equation over here is I4 equals to I2 plus this is I2. I2 equals to I3 plus I4. Okay, and you rearrange, you will get I4 equals to I2 minus I3. Okay, and you know that I4 equals to 4 ampere. So that's why we have the equation 4 equals to I2 minus I3. Okay. So, okay, so someone asked, can you put this example in ULearn? Okay. So later I will put this example in the ULearn. Okay. Okay, so so this is equation 1. This is equation 2. Okay. Next, what you need to do, set the fourth step. Okay, remember the step, 5 step. So the fourth step is substitute each current with the Ohm's law. So Ohm's law is V equals to IR. So I is actually V divided by R. Okay, so now I1 is over here. So using the Ohm's law, I1 is actually V1. Okay, this is V1 minus 0. Why 0? Because at this point, this is equals to 0 volt. Because this is connected to ground. That's why it is V1 minus 0. Divide by the resistor is 2. Get it? Okay. I2 is over here. So I2 is actually V1 minus V2 divided by R. The R is 6 ohm. That's why you have I2 equals to V1 minus V2 divided by 6. And I3 is over here. So it is actually V2 minus 0, because this is 0, divided by 7. Okay. Next, solve the simultaneous equation by substituting this equation, I1, I2, and I3 into equation 1 and equation 2. Okay. So from equation 1, this is I1. This is I1 plus I2 equals to 1. Okay. Oh, sorry. Okay. This equation. Okay. Put equation 3 into equation 1. So you will get V1 divided by 2. Why V1 divided by 2? Because I1 over here is V1 minus 0. Okay, so V1 minus 0, that's why I write as V1 divided by 2. Okay, plus I2. So I2 is V1 minus V2 divided by 6 equals to 1. Okay, you simplify this equation. Over here, I actually multiply this with 3. Okay, so that's why I get this equation. So 3V1 plus V1 minus V2 divided by 6 equals to 1. Then only you will get this equation for V1 minus V2 equals to 6. Okay, this is your mathematics. You should know this. Okay, basic mathematics. Next, from this equation, equation 2, you have I2 minus I3 equals to 4. So this is I2. I2 is V1 minus V2 divided by 6 minus I3. So I3 is actually V2 divided by 7 is equals to 4. Okay. So solve for this one, you will get the equation 7V1 minus 13V2 is equals to 168. Okay, so now you have two equations. The first equation is this equation, 4V1 minus V2 equals to 6. The second equation is 7V1 minus 13V2 equals to 168. Okay, so what you need to do next is you need to solve for the simultaneous equation. Mathematics. Okay, you have two equations with two unknowns. You must find the unknown V1 and also V2. Okay, actually you can find V1 and V2 directly using your calculator. I hope you know how to find V1 to solve for a simultaneous equation using your calculator. Okay, but if you don't want to solve using calculator, then you can solve it manually. Okay, calculate like this. Okay, so this is the first equation, this is second equation. Okay, so to solve for this one, I make this equation multiply with 13. Okay, so if I multiply this equation with 13, I will get 52V1 minus 13V2 equals to 78. Then I add these two equations. So because this is negative 13V2 and this is negative 13 V2. So if I plus this negative 13 plus negative 13, then this will become 0. Correct? This will become 0. So 7 plus, over here 7 minus 52, you will get negative 45. Over here 168 minus 78, you will get 90. So V1 is actually negative 2 volt. Okay, so after you find V1, then you can find the V2, which is equals to negative 14 volt. Okay, all of this simple mathematics. You should know how to calculate for V1 and V2. Any question? Do you know how to solve simultaneous equation using calculator? Do you know how to solve simultaneous equation using calculator? Tahu, okay.
By clicking the EQN symbol.
Yeah, okay. Okay, so my advice is that I think is better for you to use your calculator. But you must make sure that the value that you insert in your calculator is correct lah. Okay. Instead of you do it manually. Okay. Because if you have this example, this example is quite simple. Okay. But what happens if you have 3 unknown? For example, you have V1, V2 and V3. This one is very complicated if you want to solve it manually. So my advice, please use your calculator to solve for the simultaneous equation. Okay?
Madam.
Ya.
Masa SEM 1 tahun 1 hari tu, untuk statik ada apa ni? Ada soalan yang guna simultaneous equation juga. Then bila guna, sebab kan ada 2 version calculator kan, calculator hitam ni dengan calculator warna silver tu. Dia dapat jawapan berbeza je, madam.
Bisa sangat ke?
Boleh tahan juga lah, jauh dia.
Tak pernah try lah sebab biasa saya pun pakai yang ini. Saya pakai yang calculator ni. So kalau boleh beza ke salah masuk value? You should get the same. I think you should get the same. Ataupun awak salah masuk value. Tu je. Okay. Saya tak pernah guna yang calculator silver tu, so saya tak tahu. Okay. So okay, so next example 3.2. I think this is the last example. Yes. So this is the last example. So over here, given a circuit like this, and the question asks you to find, because you have 3 nodes, so you need to find V1, V2 and also V3. Okay, so you look at here, you have 3 nodes, 1, 2 and 3. So this is V1, this is V2 and this is V3. Okay. So now let's do example 3.2. Okay, so this one I will upload it in the uLearn. Okay, so this is example 3.2. So remember the 5 steps. So the first step, assign nodes as V1, V2 and V3. So you have 3 nodes, 1, 2 and 3. So I assign this as V1, this as V2, this as V3. Okay. Next, determine the current direction and name the current. Okay. So over here, this branch follows the current source. Okay, so the currents flow like this. Okay, so the I1, this is the current flow for current direction for I1. This is IX. Okay, and then I3 will the current will go to the ground. Okay, and I2, this is the current direction. This is I1. This is the same current I1, and you have another current over here. So the current over here follows the dependent current source. So this is actually 2Ix. Okay. So after you determine the current direction and you label the current, then you need to do KCL at each node. Okay, so this is the first node. So KCL at the first node is I equals to I1 plus Ix. Okay. So I is 3. So that's why we have 3 equals to I1 plus Ix. Okay. And then substitute each I with Ohm's law. So I1 over here, this is I1. So using Ohm's law, I1 is actually V1 minus V3 divided by 4. Okay. V1 minus V3 divided by 4. Ix is over here. So Ix is V1 minus V2 divided by 2. Get it? Okay. Then you calculate for this equation. This is, I calculate this one as 1 over 4 V1. That's why we have 0.25 V1 minus 1 over 4 V2. So 1 over 4 is 0.25. This one is 1 over 2. That's why I get 0.5. Okay, 0.5 V1 minus 0.5 V2. So my final equation for the KCL at node 1, I get 3 equals to 0.75 V1 minus 0.5 V2 minus 0.25 V3. Okay, so this is equation 1 at node 1. Now do KCL at node 2. So node 2 is over here. So Ix is equals to I2 plus I3. So Ix is V1 minus V2 divided by 2. I2 is V2 minus V3 divided by 8. And I3 is V2 minus 0 divided by 4. Okay, and your equation, you will get negative 0.5 V1 plus 0.875 V2 minus 0.125 V3 equals to 0. So this is equation 2. Okay, so because you have 3 nodes, then you need to have 3 equations. So the last equation, you do the KCL at node 3. So node 3 is over here is, this is 2Ix. 2Ix is equals to I1 plus I2. Okay, so Ix is V1 minus V2 divided by 2. Okay, then you multiply with 2 is equals to I1. So I1 is V1 minus V3 divided by 4. I2 is V2 minus V3 divided by 8. Okay, and you will get this equation, negative 0.75 V1 plus 1.125 V2 minus 0.375 V3 equals to 0. Okay. So you have 3 equations. Just use your calculator. You should get V1 equals to 4.8 volt, V2 equals to 2.4 volt, V3 equals to negative 2.4 volt. Okay. So untuk siapa yang tanya tadi, using the silver calculator, you get the wrong answer. Maybe you can try for this example. If you still get the different answer, then I think you should, maybe in your final exam, please use the Casio 570 MS calculator. Okay. Try to use your calculator for this example first. Okay. So any question? I hope that you understand the nodal analysis. Nodal analysis is very important, yeah. So you must know how to solve for the nodal analysis. Okay. This one, this is actually your tutorial. Okay. But I don't want to discuss it now. Okay, I want you to do it by yourself. Over here, you already have half of the jalan kerja. Okay, and you need to continue. Okay, same for this one. This is number 29, this is number 31, this is number 33. The solution is not complete, so please redo this tutorial too. Okay, by referring to this slide. But the solution in this slide is not complete. So if you look at your ULearn, okay, so I have uploaded the video for last week. And actually for last week we actually cover for the R equivalent, right? So for last week, actually you can do the tutorial from question number 14 until 28. Okay, so previously you have done your tutorial from question 1 until 13. So that's actually cover KVL and KCL. Okay, so number 14 and until number 28 cover the last week lecture, which is the R equivalent. And for this week lecture, week 5, we have covered on the Wye-Delta and also the nodal analysis. Okay, so basically for tutorial question number tutorial 2, question number sorry week 5. Okay, so this week for the nodal analysis, you can do question number 29 until number 31. Okay, ada jawapan for question 1 until 13? Ada. Saya ada jawapan for question 1 until 13. Okay, boleh share tak? Saya tak tahu saya buat betul ke tak. Do you get the same answer? Do you get the same final answer? Because in your tutorial you have the final answer, right? Okay. I will share the answer for all the tutorials actually, but I want you to do it by yourself first. Okay. So maybe I will finish. So next week we will finish this chapter 2. We will finish chapter 2 next week. So maybe after next week I will give the solution for tutorial 2. Okay, is it okay? Please do tutorial 2 by yourself first. Okay, then only you compare with the answer. Okay, so actually next week we have electrical part. Okay, and the following week then we will start to cover for the electronics. Okay, so this subject covers electrical and electronics. So next week we have finished the electrical part, and the week 7 until week 14 we will cover on the electronics part. And your midterm test, I'm not sure yet the date for your midterm test, but your midterm test will cover chapter 2. mostly chapter 2 and a little bit of electronics part. Okay, but the calculation is chapter 2. Okay, so that's why I told you that the nodal analysis, mesh analysis that we will learn next week is very, very important. Okay, because the calculation for in the midterm test is from chapter 2. Okay, 80% from the midterm test is chapter 2. Okay, so any question before we end our class for today? Is your quiz okay? Any problem with your quiz? I haven't marked your quiz yet, but I will upload the answer for quiz 1 in the Ulearn. Okay, because this is your quiz is online, right? So I cannot give back your quiz. Okay, the ones that I already marked, I can only give you the answer for the quiz, the solution for the quiz 1 later. Okay. Okay, so if no questions, then we will stop our class. We will end our class for today. Okay, and we will continue next week on Tuesday, the last subchapter for chapter 2. Okay, thank you.
Thank you, Doctor.
Thank you.